Have you ever pondered over the power of an atom? Can something so minuscule fuel our cities and industries? Welcome to the enigma of nuclear energy, a force so powerful yet so minute that it has the potential to illuminate the world or, if mismanaged, wreak havoc on it. Nuclear energy, harnessed from the nucleus of an atom, has been a cornerstone of global energy production for more than half a century. The ability to harness the energy contained within an atom's nucleus was a scientific breakthrough that opened up a new frontier in energy production. This colossal power source has been used to generate electricity in countries all over the globe, from the United States and France to China and Russia, powering cities and industries. It has also been the subject of intense debate, with its potential for catastrophic disaster balanced against its promise as a low-carbon energy source. There are several different types of nuclear reactors, each with its own unique design and operation method. These include pressurized water reactors, boiling water reactors, and natural uranium gas graphite reactors. Each of these designs has its own strengths and weaknesses, but all serve the same purpose: to harness the power of the atom to generate electricity. But the world of nuclear energy is not stagnant. Cutting-edge technologies are pushing the boundaries of what is possible. Advanced reactor designs, thorium reactors, and fusion reactors are just a few of the exciting developments on the horizon. These technologies promise to make nuclear power safer, more efficient, and more sustainable. We also need to consider the difference between current CANDU reactors and small and micro and macro modular reactors. The latter are gaining traction for their flexibility, scalability, and potential for reduced costs and risks. As we unlock the power of the atom, we embark on a journey through the annals of nuclear energy history, a journey that is filled with innovation, discovery, and an unwavering quest to harness one of nature's most powerful forces for the betterment of humankind. Step back in time to the 1940s, the decade that gave birth to nuclear power. Our story begins amidst the turmoil of World War II with the infamous Manhattan Project. This was the United States' covert operation to develop the world's first atomic bomb. Yet, in this crucible of conflict, the seeds of a peaceful application of atomic energy were also sown. The project brought together some of the greatest scientific minds of the era. They pushed the boundaries of human knowledge, delving into the heart of the atom and unveiling its immense potential. By unlocking the secrets of nuclear fission, they paved the way for nuclear power. Fast forward to the early 1950s, a time of post-war optimism and technological advances. An era of firsts. Among these was the world's first electricity-generating nuclear power plant established in the United States. Known as Experimental Breeder Reactor 1, or EBRI, it marked a significant milestone in the history of nuclear power. EBRI was a modest facility capable of powering just a few electric heaters. However, its significance lay not in its size, but in its symbolism. It demonstrated that nuclear energy could be harnessed to generate electricity, setting the stage for the development of much larger nuclear power plants. The success of EBRI sparked a flurry of activity in the field of nuclear energy. Countries around the world began exploring the potential of nuclear power, leading to a proliferation of reactor designs and technologies. From pressurized water reactors to boiling water reactors and natural uranium gas graphite reactors, the landscape of nuclear power was rapidly evolving. By the end of the 1950s, nuclear power had transitioned from a wartime tool into a peacetime resource. It was seen as a promising source of energy that could fuel the world's growing demand for electricity. The atomic age had dawned, and with it the dawn of nuclear power. From a wartime project to a peacetime powerhouse, nuclear energy had begun its journey. The stage was set for the evolution of reactor designs, the exploration of cutting-edge technologies, and the advent of the modern era of nuclear power. The nuclear power landscape is not monolithic, but a mosaic of diverse designs. In the vibrant tapestry of nuclear energy, different reactor designs play their unique roles. The pressurized water reactor, first and foremost, is the most common type. It operates on a simple principle. Water under high pressure is used to cool the reactor core and transfer heat to a secondary circuit. This process generates steam, which drives turbines to produce electricity. Think of it like a high-stakes, steam-powered engine. Only the stakes are the well-being of our planet. Next, we have the boiling water reactor. This design simplifies the process by eliminating the secondary circuit. Instead, water in the reactor core is boiled directly to create steam for power generation. It's like making a cup of tea, only instead of a cozy afternoon beverage, you're producing energy for thousands of homes. Then there's the natural uranium gas graphite reactor. Now this one's a bit of a mouthful, but it's unique in its use of natural uranium and graphite. This design uses graphite as a moderator and carbon dioxide gas as a coolant. It's like a sophisticated nuclear-powered soda machine, turning raw materials into carbonated power. Now these designs might seem different, and they are, but they all share a common goal: to harness the immense power of nuclear fission, the process of splitting atoms to release energy. Each design takes a unique approach, leveraging the strengths of different materials and processes to maximize efficiency and safety. It's this diversity that has allowed nuclear power to spread across the globe, adapting to different environments and energy needs. From the chilly coasts of Sweden to the hot deserts of Arizona, these reactor designs have found their home, each contributing to a cleaner, more sustainable future. These diverse designs pave the way for nuclear power's global expansion. And as we look towards the future, it's exciting to imagine what new designs will emerge, pushing the boundaries of what's possible in nuclear energy. Hold on to your hats, we're venturing into the future of nuclear power. Imagine a world where nuclear power is not only safe, but also sustainable and efficient. That world might not be as far off as you think, thanks to advanced reactor designs, thorium reactors, and fusion reactors. First, let's dive into advanced reactor designs. These are the next generation of nuclear power plants designed to be safer and more efficient than their predecessors. They incorporate passive safety features that require no operator actions or electronic feedback to shut down safely in the event of a particular type of emergency. This reduces the risk of human error and makes them less vulnerable to external threats. However, the challenge lies in their high initial cost and the long, complex process of regulatory approval. Next up, we have thorium reactors. These reactors use thorium, a naturally occurring radioactive element, instead of uranium. Thorium is 3 to 4 times more abundant than uranium, making it a more sustainable option. The beauty of thorium reactors is that they produce less waste, and it's harder to weaponize the byproduct. The downside: thorium reactors are still in the experimental stages, and it will take a significant amount of time and resources to make them commercially viable. Finally, let's talk about the holy grail of nuclear power: fusion reactors. Fusion is the process that powers the sun, and if we can harness it, we could potentially have a nearly limitless clean source of energy. Fusion reactors have the potential to produce 4 times more energy than fission reactors. The challenge? Well, achieving fusion is like trying to hold the sun in a bottle. It requires extreme temperatures and pressures, and so far we haven't been able to sustain a fusion reaction for more than a few seconds. The future of nuclear power is as exciting as it is complex. And while we still have a long way to go, these cutting-edge technologies give us a glimpse of a future where nuclear power could be the answer to our energy needs. From the colossal to the compact, modern reactor designs redefine the scale of nuclear power. Let's dive into this fascinating world of micro and macro reactors. The CANDU, or Canada Deuterium Uranium, reactors are a type of nuclear power plant used worldwide. These reactors utilize heavy water as a moderator and coolant, and natural uranium as fuel. They have been the workhorses of the nuclear power industry, with their power output ranging from 600 to 900 megawatts. However, the winds of change are blowing. Enter the world of small, micro, and macro modular reactors, or SMRs. SMRs are a new wave of reactors that are smaller in size, but pack a punch in terms of efficiency and safety. They range from under 20 megawatts for the micro versions to up to 300 megawatts for the macro versions. So what's all the buzz about these new kids on the block? Well, their smaller size makes them more flexible and cost-effective to build. They can be constructed in a factory and transported to the site, reducing construction time and costs. Because of their modular nature, additional units can be added as demand increases. These reactors also increase safety. They have less nuclear material, reducing the potential for catastrophic failure. Moreover, many SMRs are designed to be walk-away safe, meaning they can safely shut themselves down without human intervention in case of an emergency. But the benefits of SMRs don't stop at safety and cost-effectiveness. They can provide power to remote areas where larger reactors would be impractical. They can also be used for non-electric applications, such as desalination or hydrogen production. From its inception to its future, nuclear power continues to evolve, promising to play a pivotal role in our energy landscape. As we move forward, the micro and macro of modern reactors will undoubtedly redefine what we think of when we hear the term nuclear power. Our journey through nuclear power's past, present, and future has been illuminating. We've traveled from the dawn of nuclear energy, with its humble beginnings, to its evolution into a powerful force in the global energy landscape. We've explored the intricacies of reactor designs, from pressurized water reactors, boiling water reactors, to natural uranium gas graphite reactors, each with its own unique capabilities and challenges. We've also delved into the cutting edge of nuclear technology, where advanced reactor designs, thorium reactors and fusion reactors are revolutionizing the way we think about nuclear power. The shift from the current CANDU reactors to small, micro and macro modular reactors shows the versatility and adaptability of nuclear energy. And while we've covered a lot of ground, remember that this is just the tip of the iceberg. As we power into the future, we continue to unlock the atom's potential, shaping the course of our energy destiny.